Imagine if one day you looked up into the night sky and saw Mars or Saturn where the moon was supposed to be. That would sure turn our Earth into an alien world. And not just because of the new view. How would replacing the moon change the Earth's orbit? What planet could we safely replace our moon with? And what planet would be the most disastrous? This is What If, and here's what would happen if another planet replaced our moon. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling, now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. We can thank the moon for predictable weather, ocean currents, and the circulation of important nutrients. The moon also helps stabilize the Earth's tilt. Take away the moon and the Earth would go wobbling all over the place, and it would cause what I can only describe as climate change on steroids. But we wouldn't just let the moon take a day off. We would find it a replacement from another part of our solar system. So, what would happen if we swapped our moon with a planet that is 41 times its size? Before we get to that dramatic part, let's talk about Pluto. Pluto wouldn't look much different than our current moon. It would be smaller though, and this wouldn't be good for Earth. That's because Pluto's gravitational pull would be weaker than that of the moon. Earth would begin wobbling all over the place, and it would result in dramatic climate change. All sorts of natural disasters ruining your day. The moon's gravitational pull is responsible for our daily ocean tides. Because Pluto is smaller than our moon, our ocean tides would become weaker. This would devastate important ecosystems. Well, how about a planet that is slightly larger than our moon? Mercury would look exactly like our moon, with its dark gray surface and asteroid craters. And it's only 1.5 times the size, so its impact on our tidal systems and climate wouldn't be as disastrous. Out of all the planets in our solar system, Mercury would be the safest one to replace our moon. But I can't say that about Mars. Having the red planet in our night sky would be quite a sight. All the iron oxide on its surface would glow red. No more white moonlight shining through your window at night. Instead,
everything would be bathed in an eerie red. Ugh. Mars's stronger gravitational pull would make tsunamis smaller, but it would make normal waves massive. And because Mars would create stronger tidal forces, Earth's rotation would slow down. The days on Earth would become longer. I hope we'd still keep a 40-hour work week, because a 16-hour workday doesn't sound that great. Moving on. With Venus in our night sky, we might never experience darkness. Venus is the brightest planet in our solar system. It would reflect 60% more light than the moon. And because it's 3.5 times the size of the moon, it would force the Earth into a binary system. Earth and Venus would rotate each other. It would be beautiful and disastrous. Simulations of a binary system usually end up with planets colliding or merging. Neptune and Uranus are both ice giants and are similar in size. A huge portion of our sky would be taken up with a blue-green planet. Only Uranus would also stink horribly. No wonder this fart-smelling planet got such a name. Since both Uranus and Neptune are 14 to 15 times the size of the moon, their impact on Earth's rotation and tidal systems would be drastic. Beach houses would have to be built up on cliffs, far enough away from the reach of enormous waves. Now, seeing Saturn up in the night sky has to be my favorite. Its pale yellow color and ring system would be stunning, but there would be some complications. Because Saturn is so large, the Earth would quickly become its moon. And if Earth orbited around Saturn, it simply wouldn't be the Earth as we know today.
Finally, moving on to the big guy, Jupiter. At 41 times the size of the moon, you wouldn't even be able to see the north and south poles of the gas giant. Similar to the deal with Saturn, Earth would become Jupiter's moon. Only it would get worse. Because Jupiter is so massive, the side of the Earth that's closest to Jupiter would experience a stronger gravitational pull than the opposite side. This would distort the shape of the Earth. All this pulling apart would create frequent volcanic eruptions and violent earthquakes. Jupiter's gravitational pull would tear the Earth apart. So enjoy the view while it lasts. This is not how I pictured my day. Catastrophic planet-wide tides flood cities. Pitch black nights. An ice age more powerful than Earth has ever seen. And tungsten-shaded evening skies. This is what would happen if we swapped our moon with other moons in the solar system. And spoiler alert, you're not surviving most of these. Let's start this epic show with the truly titanic moon, Titan. You are used to our regular old moon. You're used to its size, the look of its surface, covered in gray lunar regolith. What you're not used to seeing is this up in the sky. Yeah, that's Titan. This moon of Saturn is a behemoth. It's the second largest moon in the entire solar system. It's even bigger than the smallest planet, Mercury. Unlike Mercury, it's icy cold. We're talking minus 180 degrees Celsius. That's minus 290 degrees Fahrenheit. Its surface is covered with rivers, lakes, and seas, just like Earth, except that these bodies of liquid are not made of water. That's methane, and you shouldn't swim in it. You'd see a big change on Earth if we swapped our moon with Titan. Instead of that silvery white light, our nights would take on a golden orange twilight, and our new Titanic moon would loom larger in the sky, as it's about 1.5 times the size of the old moon's diameter. But Titan is a very special moon. It has a thick, nitrogen-rich atmosphere that stretches almost 600 kilometers into space. So our new moon would appear like a giant, fuzzy orange orb. So far, not a big deal. Unless you hate orange, or rhyming things with orange. But things are about to get terrible for you. Titan is 80% more massive than our moon, so its gravity would pull harder on Earth's oceans. Here on Earth, that would be a very big deal. High tides would be far higher, and low tides, obviously much lower. Now, we can deal with lower tides, but high tides would flood our coastal cities twice a day, every day. There would be more erosion and turbulence on every coast. This would be the only time you'd ever hope you don't own beachfront property, because by now, it'd be gone. Things wouldn't be the same for Titan either. After moving all the way from Saturn's orbit to ours, this moon would receive far more solar energy from the sun. It would start to heat up. For all the methane on its surface, it would be game over. Titan's methane lakes would eventually evaporate. The icy crust would begin to melt, and soon it would reveal the watery subsurface ocean that lies beneath. And that could be a fascinating moment. If any life exists beneath the icy surface in the ocean below, we'd land on Titan's surface and explore it. Now, this ocean could be hundreds of kilometers deep, but it just means there's a lot more to explore and maybe a lot more to find. The bad news is Titan has low gravity. That means it couldn't hold on to all that liquid and atmosphere forever. Over millions of years, it would bleed gases and water out into space, slowly drying out. Yeah, this moon would become just as sad and lifeless as our own moon. Bye-bye, hazy methane orb in the sky. Now, if you thought Titan was big, well, this moon is gargantuan. The only moon in the solar system bigger than Titan is Jupiter's Ganymede. It's also the only moon in the solar system that has its own magnetic field. It's about 1.5 times larger than our moon, so by night it would look about the same size as Titan, only instead of an orangish nighttime, Ganymede would shine extremely bright. Yeah, Ganymede is covered in ice, and that icy surface reflects far more sunlight than our moon does. To you on Earth, this rock would now look much, much brighter. That would be bad for astronomers because they wouldn't be able to see so far into space with this new moon overwhelming the sky. And you might have to invest in some better curtains. Well, that's not that bad so far, but stay with me. I saved the most dramatic part for later. Ganymede is about twice as massive as our moon, and its stronger gravity would unleash worldwide megatides. Like with Titan, you'd see coastal flooding twice a day, wild erosion and wave activity, and some very destructive storms. Ganymede's presence would be earth-shaking, literally. Its tidal pull on Earth's crust could trigger earthquakes and cause volcanic eruptions worldwide. The one upside, if you're around to see it, Ganymede would stabilize Earth a little. Specifically, it would stabilize the Earth's axial tilt. That would mean no more ice ages and a steady climate forever, so Ganymede itself would start to warm up. Now, you might think that the moon is chilly, but in full sun, it can reach temperatures of 125 degrees Celsius. It's 260 degrees Fahrenheit. Yeah, the moon can get hot. But Jupiter and Ganymede get roughly 1/30th of the sunlight that the moon does. And Ganymede is usually a chilly minus 112 degrees Celsius on its warmest days. It's been cold there for billions of years. As Ganymede is heating up, its immense 150 kilometer thick crust of ice would start to sublimate or even melt. This icy rock wouldn't be so icy anymore. It would now have oceans and water clouds. Beneath that crust lies an extremely deep saltwater ocean. Scientists think it's 100 kilometers or 60 miles deep. In time, you'd go vacationing on Ganymede instead of Cancun. Now, Ganymede has its own magnetic field, and it also has auroras. Imagine traveling far north to see our own northern lights, and there in the background, Ganymede's auroras as well. Pretty cool. Ganymede might destroy everything you know on Earth, but it would also become a pretty inviting rock. If you survived all these earthly disasters, well, you could go live there. Okay, moving on to a hellscape of a moon, Io. Io is the third largest moon of Jupiter, famous for its hundreds of volcanoes blasting molten sulfur lava hundreds of kilometers into space. Io is the most volcanically active body in the solar system because it's subjected to a phenomenal gravitational push and pull between Jupiter and its hefty moons, Europa and Ganymede. The tidal forces cause extreme physical distortion and create intense heat, and that heat unleashes itself through endless volcanic activity. Volcanoes and molten lava lakes cover the surface of this virtual inferno, which would make for a pretty phenomenal show the moment we swapped it out for our comparably static moon. Our moon hasn't had volcanoes for millions of years. Io would be spectacular to watch from Earth. By night, it would shine 5 times brighter than our old moon, with a golden orange glow. You'd be able to see Io's volcanoes erupting with a simple telescope. But as hellish as Io might sound, it wouldn't be so bad a companion for Earth. You see, Io is quite similar in size and mass to our moon. You might see a slight increase in the tides, but nothing disastrous. And without Jupiter, Europa, and Ganymede constantly playing a gravitational tug-of-war with Io, the new moon would immediately stop being torn by the three-way stress that heated it mercilessly and caused all those volcanoes. Io would cool down, the volcanoes would go dormant, and our new moon would eventually turn cold and quiet, not unlike our current moon. So, what would happen if we swapped our moon with another famous moon of Jupiter? Next up, Europa. This is one of the most famous moons in history. Since Voyager flew past Jupiter and Europa in 1979, scientists have been intrigued by Europa's icy crust and possibility of an ocean beneath it, which, of course, opens up the possibility for life. But Europa has even more surprises. Back in the 1990s, NASA's Galileo spacecraft picked up something odd when it was studying Jupiter's magnetic field. Right in the spot where Europa orbits, the field looked strangely distorted. Now, Europa doesn't actually have a magnetic field, so where was this disruption coming from? Scientists think this answer lies beneath its icy shell. Europa might have a vast underground ocean of salty water, and as Jupiter's magnetic field sweeps past, it stirs up the electrical currents in that ocean. These currents create a temporary magnetic effect, which is what Galileo detected. This ocean on Europa could be up to 150 kilometers, that's 100 miles deep. It's quite a bit for a moon. For comparison, the deepest depth of an Earth ocean is only 11 kilometers, 6.8 miles. So yeah, swapping our moon with Europa would affect you on Earth. For one, Europa's icy crust would reflect more than 5 times the light that our moon does. And it has a lower mass, so our tides would be weaker. Over millions of years, Europa would make Earth's axial tilt a little more unstable and cause some huge climate swings on our planet. But before Europa had a chance to destabilize Earth, you'd have a better look at it. Okay, now you wouldn't have to send a spacecraft nearly 3 billion kilometers, 1.8 billion miles, to study this moon. At just 385,000 kilometers, that's 238,855 miles from Earth, Europa would be just a 3-day trip away. NASA's planning to have people back on the moon by 2027, and that means we could have people walking on Europa in just a few years, studying its surface, searching for life. Now that is cool. Sure, in time, Europa's subsurface ocean would begin to freeze. Jupiter wouldn't be around to exert the same kind of tidal squeezing it has for billions of years. And its surface would start to warm up, melting or sublimating its ice. Over time, Europa would go from a mysterious ocean world to a frozen, quiet moon. But in the meantime, maybe we'd find we're not the only ones out here. Okay, up next, another frozen moon, but one that doesn't play by the rules. Triton. Triton is a weird moon. It's the largest moon of Neptune, and it's the only sizable moon in our solar system to orbit in the opposite direction of its planet's rotation. The scientists call this a retrograde orbit. Now, if we swapped not just our moon, but also the direction it's going, that means our new moon, Triton, is going the wrong way. Triton is another one of these highly reflective icy moons that would light up the sky, but it's not nearly as massive as our moon, which means Earth's tides would drop dramatically. Instead of the moon being the primary driver of our twice-daily tides, the sun would take that role, and the sun only exerts about half of the tidal force that our moon does. Over millions of years, lacking a strong lunar anchor, Earth's axial tilt would wander more, leading to unpredictable shifts in climate and more extreme ice ages. But when it first shows up, Triton would put on a show. Bright, retrograde, and sporting ice volcanoes. That's right, outside of Earth and Io, Triton is one of the most volcanically active spots in the solar system. Except it's not spewing molten rock, it's venting cryomagma from cryovolcanoes, which is really just a fancy way of saying it's erupting ice up to 8 kilometers, 5 miles, into its atmosphere. So we'd have a front row seat every night to watch our moon blast cryomagma out into space. Out by Neptune, it's so cold that the ice on this distant moon is made of frozen nitrogen, water, and methane. Triton's surface is one of the coldest places in the solar system, reaching a frigid minus 235 degrees Celsius. That's minus 391 Fahrenheit. Now, being so much closer to the sun, its surface would quickly start to warm up, and all that frozen nitrogen would be vaporized, which could create a thick, hazy atmosphere, maybe even a comet-like tail. Over the centuries, Triton would slowly lose its icy shell, and if it has an ocean beneath it, that would begin to dissipate as well, eventually becoming a smaller, drier remnant of its former shining self. But in its early days, Triton would light up the night and put on quite the show, unlike our next moons, Phobos and Deimos. So far, we've mostly swapped our moon for huge or medium-sized moons, but our next-door neighbor Mars sports a pair of satellites that are tiny. Phobos and Deimos are officially moons, but they might just be asteroids that Mars caught in its gravity and they now orbit around the red planet. Phobos, the big sibling, is only 27 kilometers wide. That's 17 miles wide at its widest point. Deimos is even smaller, only 15 kilometers, 9 miles across at its widest point. And I say at its widest point because we can't even get a normal diameter. These moons are completely irregular. They're also more than 100 times smaller than our moon. And they're covered in craters, charcoal-hued dust, and rocks. So if we swapped our moon for the pocket-sized Phobos and Deimos, boop, paint it black. there'd hardly be anything in the night sky at all. Our new moons would basically look like bright-ish stars or satellites zipping around in the sky. You wouldn't be able to pick them out of the constellations. Nighttime would be pitch black. Moonlight, as you know it, would disappear, which would wreak havoc on our nocturnal species across the globe. Good news for astronomers, but for everyone else, swapping out the moon with Phobos and Deimos would be a complete disaster. With hardly any comparable mass, well, the tides would almost be entirely driven by the sun. As oceanic tides drop dramatically, marine life would be so heavily affected that you could actually see the collapse of coastal ecosystems. This would change wind, waves, and global heat regulation. And worse, over millions of years, Earth would start to wobble wildly. Say that 10 times fast. Earth would start to wobble wildly. This means unpredictable seasons, ice ages, and droughts. Imagine the North Pole winding up at the equator for 50,000 years. Even more, and this one is wild, it could lead to the end of life on Earth as we know it, or at least an extinction level event. Phobos is slowly falling into Mars. It gets about 2 meters closer to Mars every century. That's 6 feet closer. In about 50 million years, it's either going to break up and shatter into a very small version of Saturn-like rings around the red planet, or it's going to crash directly into it. So if Phobos is our new moon, well, you'd be looking at a 27-kilometer wide moon asteroid plowing into us in slow motion. That could be twice as big as the asteroid that wiped out the dinosaurs. So, yeah, extinction. Gotta say, I prefer our current moon to these guys. Okay, next up, the final moon of this swapping list, Enceladus. Enceladus is a frozen ice ball spinning around the far rings of Saturn. But it's got something cooking under the hood. It's not just riding along on the rings, it's actively contributing to the creation of Saturn's outer E-ring. Yeah, Enceladus is spraying icy water particles and gas into space. What does that mean for you once we swap our moon for Saturn's? Well, Enceladus is covered in fresh ice particles and snow, making it the whitest, most reflective surface in the solar system. So even though it's relatively small compared to our moon, it's still going to shine brilliantly. Nights would be dimmer, but nowhere near as dark as with the miniature moons of Mars. The problem with Enceladus, like any smaller moon we tag in, is that its mass is too small to create the same tidal forces that we're used to on Earth. You got it. So losing our moon and replacing it with Enceladus would essentially recreate the Phobos and Deimos disaster. Cue dramatic drops in oceanic tides, coastal catastrophes, and wild climate uncertainty. And eventually, unstable planet tilting. But at least you'd still be able to see at night. Though it wouldn't take long before all that ice started to sublimate and maybe melt. Enceladus's ice shell isn't nearly as thick as some of the bigger moons like Europa, so soon you could see oceans of water on our new moon. Hey, if it means we get another shot to see if life exists anywhere else in the solar system, I'm in. That's pretty cool. In short, swapping our moon with other moons is a neat idea, but if the moons are too big or too small, they'd cause catastrophic damage to our fragile coastlines and most of the planet. So while I'd love a chance to check out all the volcanoes from the moons of Neptune and Jupiter, I think I'll stick to our good old moon. After all, this is the closest place in the solar system you can deliver a burger to. But that's a story for another Chase Dies in Space. It's been 150 days since the moon has been on a collision course headed right toward Earth. As the moon gets closer, ocean tides are rising, our cities are being flooded and destroyed, volcanoes and earthquakes are erupting around the world. The moon's gravitational pull is getting stronger and wreaking havoc on our planet. But wait, how did we get here? Well, let's go back. With just 1 year until the moon hits Earth, we'll take you through each major phase of its approach, detailing the consequences and figuring out if we have any chance at stopping it. T minus 365 days. Okay, the moon is ridiculously far away, 384,000 kilometers away. For reference, the circumference of Earth is just over 40,000 kilometers. Well, with this kind of distance, you could fit every planet in our solar system in the space between Earth and the moon. So this celestial body has a long way to travel, but at this moment, it's headed right for us. At first, you probably wouldn't notice anything. If you were on an ocean beach, maybe you'd find the waves splashing up a little bit higher on the sand, a result of the moon's gravitational pull on our largest bodies of water. But wait, let's take a second. Why is the position of the moon so important to us anyway? Well, the moon plays quite a few essential roles in helping out life on Earth. We'll get to that in a second, but first, why does it stay up in the sky? Well, that's got to do with gravity. The moon orbits the Earth at a speed of over 1 kilometer per second. That's pretty good velocity, and I'm sure it would love nothing more than to roam freely throughout space. However, since the Earth is so much more massive, Earth's gravity pulls on the moon, preventing it from being flung out into space. But what does the moon do for us down here on Earth? Well, one thing it does is help stabilize our climate. More on that later, but if the moon starts moving toward us, instead of seasons changing, we might get extremely long periods of cold in the Sahara and some extremely hot weather up in Canada. That one I wouldn't mind so much. But what I would mind, our ocean tides changing drastically because of the moon's shifting. You'll see why soon. Oh, and I forgot to mention, at the speed the moon is currently moving, it would actually hit our planet in a little under 5 days. So let's slow it down and give us a year in order for us to have enough time to see if we can solve the problem. T minus 300 days. Okay, the moon started 384,000 kilometers away from Earth, but now it's 250,000 kilometers away. With the moon this much closer, it's heavily affecting our oceans. Rising tides are reaching up to 5 meters. This is flooding our coastal cities. Places like New York, Miami, London would all be underwater. Buildings would be destroyed and citizens would be forced to evacuate. But that's not all. Any animals that live on the coasts, like sea turtles and pelicans, would be displaced due to the rising waters. And the salt water from the ocean could leach into our freshwater supplies, leading to contamination. Now, this is only the start, and the moon is getting closer and closer. While we wait for that to happen and cause even more destruction, you might be asking, has this ever happened before? Well, to investigate, we sent our correspondent Rose to find out more.
This whole scenario got me thinking, how do we know that the moon affects our tides so much? Maybe in order to understand that, we need to look at Earth's past first. I'm talking 4.5 billion years ago. Let me show you what I mean. I'm here at Western University to talk to Dr. Gordon Osinski, one of Canada's leading lunar researchers, to get some answers. So, has something like this happened on Earth before?
An object the size of Mars that we now call Theia impacted Earth just after our planet formed. We actually think that this is how the moon formed in the first place. The Earth formed, the other planets of the solar system formed, but also some other planets that no longer exist. And for reasons that we don't know about, one of these, called Theia, came close enough that it hit Earth, and out of this cataclysm, the Earth essentially reformed, and then the moon formed out of the disk that was present around the Earth.
How do we know that they hit Earth in the past? It was so long ago.
And one of the biggest bits of evidence that we have is actually thanks to the Apollo mission. Things that we keep learning from the Apollo missions is from the samples that the astronauts brought back. And when geologists first started looking at these samples, they realized that they're really similar to rocks we have on Earth. In some places, sometimes identical. And so this really tells us that the moon and the Earth formed out of the same starting material. And we actually have samples of the moon here on Earth, and actually here in this lab, that we can take a look at, and we'll see that actually, the properties and what these rocks actually look like from the moon is very similar to the rocks we have here on Earth.
Got the gloves on, and we're gonna touch a part of the moon.
This is indeed a sample of the moon. It's not an Apollo sample, but this is a meteorite, and so we actually have quite a lot of meteorites now that have come from the moon from some impact event that kind of ejected them. And you can actually see that in this sample because this is the original outer surface that got a bit weathered in the desert of West Africa. And then we've kind of cut this sample to reveal the inside.
So in a way, the moon is already clashing into the Earth and hitting it, but just in much smaller bite-sized bits.
Absolutely.
T minus 200 days. Okay, the moon is now just 100,000 kilometers away from Earth. Things are only getting worse for our planet and everyone involved. Tides are reaching up to 30 meters high. Every city near the water will be uninhabitable. Infrastructure near these cities will completely collapse. No more subways, trains, all roads and highways will be flooded. Everything.
But why is this happening? Well, I think Dr. Osinski has our answer. What role does the moon play for Earth today?
So the biggest role that the moon plays on Earth is tides. If you've ever gone to the coast anywhere in the world, there'll be a certain level of tide. And if there was no moon, there would be no tides, which is kind of interesting to think about on its own. So the moon essentially asserts a gravitational attraction on the side of it facing the Earth. It essentially is pulling Earth's water towards it.
Let me show you a bit more of what Dr. Osinski means. Peter talks about the tides getting higher, and this is true, but luckily this wouldn't happen all the time. As the moon rotates around the Earth, it creates two bulges around the planet, one on the side facing the moon and one on the opposite. So as the Earth rotates and the moon ends up in different spots, the water bulges in these areas. This creates the rise and fall of tides throughout the day. Now imagine this process being exaggerated to extreme levels.
If we go back billions of years ago and we look at rocks that were formed, in the coastal regions where they were influenced by tides, we do see really dramatic evidence that the tides were substantially higher than they are at the present day. And our explanation for that is because the moon started off much closer to the Earth than it is at the present day.
So it would be the very key role that the moon plays on Earth now that would essentially lead to its own destruction if it came any closer. But luckily for us, that's not happening anytime soon. I've heard that the moon is actually moving away from us about 3.8 centimeters a year, but do we know why it's moving away from us?
When scientists first discovered that the moon was moving away from the Earth, they really didn't have an explanation. But it was actually the development of these, this giant impact hypothesis, this model of Theia impacting Earth and creating the moon. It actually provides a solution because all of those models suggest that when this event happened, the moon actually formed much, much closer to Earth. And so it fits with the model. The moon started closer to Earth after it formed, and then since then it's just been moving outwards, slowly but surely over the last 4.5 billion years.
But don't worry, this won't have any significant effect here on Earth, at least not right away. In about a century, the days will get about 2.3 milliseconds longer, and in millions of years, our ocean tides might get slightly affected. But unfortunately for us, in our scenario, the moon is actually moving towards Earth. So what happens next?
Well, you'd have to go to places with higher elevation. Cities like Denver, Calgary, and Mexico City would all be good bets. They're elevated at least 1,000 meters above sea level, keeping them nice and dry from all the flooding. But that doesn't mean they'd be completely safe. If the flooding from our fast approaching moon doesn't get you, other natural disasters will. T minus 100 days. Okay, we're now just 100 days from impact, and things are only getting worse. One of the biggest things you'll notice is the changing weather all around the world. Climate patterns may completely shift, causing an increase in hurricanes and violent storms. Now, weather is one thing, but what's even worse? The volcanoes and earthquakes. The moon's gravity exerts force on the Earth's crust, and if it gets closer, well, then the force increases, causing an extreme strain on the Earth's mantle and leading to earthquakes and volcanic eruptions. Under this increased gravitational force, volcanoes could erupt all over the world. The Ring of Fire along the Pacific Ocean would be particularly vulnerable. This area of the world has about 75% of Earth's volcanoes, and it's where 90% of the world's earthquakes take place. And this would only intensify with our approaching moon. With cataclysmic events happening all over the world, everything would be getting destroyed. The cities that were safe from flooding would now be dealing with massive earthquakes and scorching volcanoes. And the moon's collision course with Earth will be happening any day now. Is there any way we could stop it? Well, there actually might be a way. In 2022, NASA ran the Double Asteroid Redirection Test, or DART for short. During this test, NASA intentionally threw a spacecraft at Dimorphos, an asteroid floating around the Sun. The spacecraft successfully pushed the asteroid off course, and now other researchers are building off this initial test. If humans keep digging into this research, it could change everything. Maybe it could even deflect the moon if it were to come after us. But wait, none of that might actually matter, thanks to the Roche limit. This is what would likely happen when our moon approaches Earth. Instead of colliding with us, our planet's gravity would overcome the moon's, causing the moon to disintegrate. T-minus 0 days. Okay, the moon is now just 18,000 kilometers away, which happens to be the approximate distance of the Roche limit. And this is the point where the moon starts to get heavily affected by Earth's gravity. So instead of the moon affecting our gravity here on Earth, our planet is now starting to fight back. Due to the gravitational shift, the moon would start to rupture and break apart into pieces, ranging from tiny dust particles to asteroid-sized rocks. Now, instead of these pieces falling down to Earth and knocking down buildings or impacting the ground like the asteroid that killed the dinosaurs, they would continue to orbit and create a ring around our planet. We'd have frequent meteor showers here on Earth thanks to the sheer volume of asteroids now floating around. And whether through gravitational force or atmospheric conditions, some of these meteors and asteroids would come raining down. Whatever animal life is left on Earth would be left extremely confused. We wouldn't be getting as much light due to the asteroid ring blocking out portions of the sun's rays. This would affect photosynthesis, both in plants and in phytoplankton. Now, less photosynthesis means less oxygen, so any life that did survive would now be dealing with trying to breathe and survive with Earth's decreased oxygen level. And due to this new ring system, there would be so many more shadows cast on the planet. Some places on Earth would be extremely cold. It could get so cold that a global cooling could occur, something that may have happened before. Yeah, over 450 million years ago, a disintegrated asteroid may have formed a ring around the Earth, similar to the one we're seeing right now. Now, this ring around the planet may have led to a global cooling event, one that dropped the temperature of Earth by 8 degrees Celsius. A global cooling like this would cause an extreme shift in temperatures, a shift that would destroy what little food supply humanity has left at this point. And because of all these roaming asteroids and the debris right above us, our communication systems would be down entirely. If anyone else managed to survive this catastrophe, well, good luck contacting them. All satellites would be destroyed, killing our communication infrastructure. With the state that the Earth is in, with all the volcanoes, earthquakes, flooding, global cooling, maybe our best bet is just to leave here. Well, let's assume that we had the spacecraft technology to support that. If we somehow managed to get a spaceship up in the sky, well, we'd be pelted by the thousands of space rocks up in our atmosphere. This ring would be a barrier to traveling, keeping all of Earth's inhabitants inside. Say goodbye to space travel and exploration. And of course, it's safe to say that in a scenario like this, pretty much everyone would die. But this is the relative immediate future. What happens decades later or a century into our new ringed future? Would humanity or Earth ever be able to make a comeback? All right, well, Rose joins us in the studio now to talk a little bit more about the moon crashing into the Earth. Hello, Rose.
Hello, Peter.
You had a nice interview with Dr. O.
Yeah.
He seems to know a lot about rocks, a lot about lunar rocks. What else did you learn in your interview with him?
So basically, my takeaway from this entire video is there's two worst case scenarios, and one is a little better than the other. A, the moon crashes towards Earth super quick and we're all dead. Everyone dies, as you say on What If quite often.
Everyone dies.
Or B, the moon comes towards Earth super slowly, causing more and more havoc as time goes by, which would also screw us over, but not as much as a direct impact would. And in this scenario, the moon would break apart into a bunch of pieces when it reaches the Roche limit, creating a potential ring around the planet.
If we do end up having a ring of moon bits around the Earth and we are still alive to view it, number one, how cool.
Yeah, that'd be so
That'd be
sick.
pretty cool.
That'd be so sick.
Number two, it would be dangerous. How?
We don't know how long it would take for all that moon debris to settle into that ring formation around the equator, right? So eventually, and we don't know how long that would be, it would look like the rings of Saturn, but initially it's gonna be a bunch of debris floating around. It's not gonna go into the equator. It's
Right.
gonna be
So it's
really-
all rocks all around the Earth.
Exactly.
Killing all our satellites, etc.
Exactly.
And by the time it forms into a ring, it could be tens of thousands,
Yeah,
hundreds of thousands of years
we
from
don't know how long that would take.
I'm dead
exactly.
by then.
Imagine like having all of these debris floating around Earth would also cause so much havoc on Earth. It would completely change our climate. It could potentially cause another ice age, I would imagine, because if it's blocking out the sun at various times, if super huge debris is moving around and a lot of the sun gets blocked and it creates a disturbance in our atmosphere as well, it would cause such a disruption and all of the ecosystems would have to change or die. So with an ice age happening, debris falling from this ring, how are you surviving this scenario, Peter?
I'm probably not surviving, depending on how many rocks you say are falling down. I don't know, how often and how intense it would be. I would probably dig a bunker underground.
You would dig a bunker?
Well, I'd have somebody dig a bunker for me.
Yeah.
I don't imagine it would save me from, a 1 kilometer wide asteroid that's going to hit Earth.
Yeah.
But at least in the meantime, I can be down there watching my YouTube videos, drinking my light beer, making macaroni and cheese.
I mean, there's a chance humanity could survive if we all lived in bunkers underground for a little bit of what's left of humanity at least. If you could bring only 5 people to live in this bunker you dig with you, who would you bring?
Well, right off the top of my head, my mother, my wife, probably my 2 kids. Depend on how they're acting that week. And 5th, my neighbor Tom, because he's very good at survival stuff. What about you?
Yeah.
Do you have 5 people that you would take?
5 people, my parents, my cat, maybe 2 of my best friends. Yeah.
We want to know what you think. So would you rather be killed instantly and painlessly, or possibly painlessly? Or would you like to watch the moon come at you for a year straight, knowing that you're going to die, and then when it hits you, everything changes and you have to work very hard to revive society? For me, it's an easy choice, but maybe you have a different point of view.
Tell us below in the comments.
Regardless of what would happen, it's safe to say that a scenario where the moon falls to Earth is virtually impossible. Remember, the moon is actually moving further away from us every year, and the gravity from Earth pulling it in is just too strong, making sure the moon stays in a stable orbit. And as cool as an asteroid ring around Earth might be, I'd rather keep our oceans and have way less active volcanoes. A new moon has suddenly appeared near Earth, except it's not orbiting our planet, It's orbiting the moon. What? A moon having its own moon? How did this mini moon form? Is it here to stay? And how would this affect us on Earth? This is What If, and here's what would happen if the moon had its own moon. Okay, before we throw ourselves into the orbit of our planet's largest natural satellite, let's take a look at how our moon came to be in the first place. To do that, let's step back, about 4.5 billion years back, to one of Earth's most impactful moments. Scientists theorize that in the early years of our solar system, there was another planet in our cosmic neighborhood, known as Theia. And even though this planet could have been about the same size as Mars, we don't have much evidence to prove it because, well, Theia no longer exists. That brings us to the Great Impact hypothesis. According to this theory, Theia and Earth were both in orbits that doomed them to a head-on collision. And when these massive celestial bodies bumped into each other at high speeds, the impact was, well, as the name suggests, quite great. Enormous amounts of material were ejected from both planets, but all this debris didn't just drift off into outer space. Instead, it formed a dense ring of molten rock, dust, and gas around Earth. And over the course of a few million years, this material lumped together under the forces of the planet's gravity, merging into one single object, an object we know today as the Moon. So, if this is the story of how our gravitational companion came to be, does that mean we should be bracing for the Great Impact Round 2? Well, that's not the only way moons can form. And by moons, I'm of course referring specifically to submoons or moon moons, which are all just different ways of saying the moon of a moon. Still with me? Okay, good. Beyond the Great Impact hypothesis, which requires millions of years to play out, there are faster routes to acquiring a moon. Some moons are fully formed objects that are captured or pulled in by the intense gravitational forces of a celestial body. Take Neptune's moon Triton as an example. Theorized to have been a large icy body in the Kuiper Belt region, it may have been captured by Neptune's gravity after a close encounter. This massive gravitational disturbance could have ejected the object from its original orbit and pulled it into its own. Over time, Neptune's tidal interactions forced Triton's orbit to go from long and elliptical to nearly circular. And in case you're wondering how this theory came to be, well, it's because Triton, unlike other large moons in the solar system, orbits in retrograde. And no, that doesn't mean its vibes are off, like when Mercury is in retrograde. It just means that it orbits in the opposite direction that the planet spins in. Okay, in order to avoid the mess of a giant collision, let's imagine that our own moon's moon was a captured object, like Triton. Maybe it was once an asteroid, passing just close enough to Earth to avoid a collision, and even closer to the moon to find itself trapped in its orbit. This would make for an incredibly delicate gravitational disruption, big enough to be locked into the moon's gravity and small enough not to disturb the moon's orbit around Earth. The object would need to be a bit of a Goldilocks. One study suggests that in order to maintain a stable orbit around our moon, this object would have to be no bigger than 1 kilometer in diameter. And even if this asteroid were to succeed in becoming a moon, well, it wouldn't stay one forever. It would be constantly tugged and pulled in different directions by the tidal forces of both Earth and the moon. That would mean there'd be a chance of it getting ejected from its orbit or colliding with the moon. So its entire lifespan as a moon might only end up lasting a few years or decades at most. During this short window of time, the moon would have little to no effect on us back here on Earth. Well, physically at least, but that wouldn't mean that it wouldn't become an object of endless fascination to us. Throughout history, the moon has been a source of inspiration for myths, legends, and folklore. The sudden appearance of a small moon swinging around it would inspire a whole new wave of stories, art, and no doubt plenty of conspiracy theories. But beyond the stories we'd get to tell future generations of our moon's moon, scientists would have an opportunity to study a celestial phenomenon like nothing we've ever seen before, and so close to home. Observatories and telescopes could focus on this tiny object to study the ways that different objects interact with forces of gravity. This would help us collect data and predict similar events happening in far-reaching parts of our cosmos. But mostly it would give you something new and exciting to gaze endlessly at in the night sky. Until one day when it may appear to drift away back into the depths of space or careen downward into a rocky impact. And if you weren't keeping a constant eye on it, well, you better hope someone was, because amid the tidal tug-of-war between our planet and the moon, there's a chance that the moon eventually collides with us here on Earth. In this event, the moon would behave just as you'd expect any asteroid to act. Headed toward Earth, it would enter our atmosphere and then begin to generate intense heat as it encounters the friction of the air in our atmosphere. Considering its small size, there's a good chance it would likely break apart before making impact. But if it stayed intact, well, that could spell trouble for us. Traveling at an average speed of 72,000 kilometers per hour, this asteroid could smack down right on top of your city. Now, the amount of energy released by an impact like this would be equal to thousands of megatons of TNT.
A giant asteroid is heading our way. But no, it won't hit the Earth. This asteroid is about to slam into the moon and crack it right in half. What would it be like to witness this epic collision? Would the moon break clean in two? Or would it shatter into a million pieces? And how could one of those pieces wipe out life here on Earth? This is What If, and here's what would happen if an asteroid cracked the moon in half. Before getting into our scenario, let me tell you about the time long ago when the moon almost exploded. It was a beautiful summer night in England in the year 1178. And 1 hour after sunset, people witnessed a spectacular phenomenon. A giant flame appeared around the upper part of that evening's crescent moon. And right before their eyes, the moon appeared to split in two before turning black. At least this is how the event was recorded by the local chronicler. As you could probably guess, the moon didn't actually split in half that night. It's possible that what these people saw was a large asteroid slamming into it. But an event like this would have sent massive amounts of lunar material toward Earth. More likely, what they witnessed was a meteorite entering the atmosphere and crossing their line of sight directly in front of the moon. This would have given the illusion of it splitting in two in a fiery fashion. But who needs illusions or questionable historical accounts when we could imagine what would really happen? Just get ready to avoid falling moon rocks. The moon is bombarded by hundreds of asteroids and meteorites every year. And without an atmosphere like we enjoy back on Earth, these objects don't burn up before impact. So even a meteorite as small as 25 centimeters across could have a big impact on the moon. In 2006, one approximately this size slammed into it. From Earth, the impact looked like a flash that lasted only 0.4 of a second. But it created a crater about 14 meters long and 3 meters deep. Taking things up a notch, a 40-centimeter meteoroid slammed into the moon at a speed of 90,100 kilometers per hour. This was such an intense collision that it caused a flash as bright as some of the stars in the night sky. That means when this happened in 2013, you could look up and see the events unfolding without a telescope. For one whole second, at least. The likeliest contender within our solar system of doing some serious damage to the moon would be Ceres. It's the largest object found in the belt between Jupiter and Mars. While it's technically classified as a dwarf planet, it's still only about a quarter as large as the moon. But even that wouldn't be enough to break the moon in two, or at least to knock it out of its orbit. For that, you'd need an asteroid almost the same size as the moon itself. And if this happened, you'd know it right away. About 1.3 seconds after impact, you'd see the moon being torn apart. Massive amounts of debris would be hurtling toward Earth. Some of this debris could be even larger than the asteroid that caused the mass extinction of the dinosaurs. But before you start picturing the life on Earth wiped out scenario, things might not be as bad as you think. Normally, Earthbound asteroids travel at speeds faster than 100 kilometers per second. But it would be different for the chunks of the broken moon and the moon-destroying asteroid. These would have much lower speeds, and with that, much less energetic impacts. If you were lucky, the impact from even the most colossal pieces of lunar debris would release only 1% of the energy of a similar-sized asteroid. Adding to your luck, you'd get to witness a meteor shower of truly epic proportions as smaller bits of debris would burn up in the atmosphere. And this epic collision wouldn't result in two split halves of the moon now orbiting around Earth. Sadly, you'd have to kiss the moon goodbye. It would be shattered into a million pieces. But if it were to somehow break more or less in two, there would be a chance you wouldn't even know. At least not right away. That's because the asteroid could have split the moon right between the side that always faces Earth and its dark side. You could still see the front of the moon beaming down on you. Eventually, the two halves could escape each other's gravity, revealing two hemispheres in the night sky. And they'd stay like that for a long time. At least until the effects of gravity, pulling each half from all sides, shape them into similar spheres. But that would take millions, if not billions, of years. If the moon is blown to bits, our night sky would be permanently transformed into a dazzling sea of stars. Venus would become the new brightest object, despite the fact that it's 14,000 times less bright than the moon once was. Some of the more drastic consequences of the moon being destroyed would start to make your life difficult. The moon is responsible for the Earth's 23.4 degree tilt on its axis. Without it, this tilt could become as much as 45 degrees. That would make our planet spin nearly on its side, and this would mean the sun would no longer shine directly over the equator. Instead, it would beam down closer to the North and South poles. This would trigger some extreme weather and could lead to ice ages that occur on different parts of the planet as often as every few thousand years. And the tides would never be the same again. Earth's powerful tides are caused by the moon's gravitational pull on our oceans. The sun's gravitational pull on our sea levels is only about half of what the moon can pull off. No longer having the moon in our orbit would lower sea levels and have a huge effect on ecosystems in intertidal zones. Tidal wetlands species would now have even more fierce competition for food and shelter. This could really endanger a lot of marine life, like sea turtles. The rising and falling of tides is an extremely important factor in giving their offspring the best chance of survival.
Scattered throughout our solar system lie hundreds of moons. each fitted with unique dangers and threats. And today, Chase will be visiting some of the most treacherous of these worlds to find out the worst each moon has to offer.
You guys are like fully sadistic, you know that, right?
We'll start with the most bizarre moon in our entire solar system, Saturn's colossal moon, Titan. Its freezing temperatures and thick atmosphere make for a very, very perilous journey. This is the only moon with a thick atmosphere, and the atmospheric pressure is 1.5 times greater than what you experience on Earth.
Can't smell anything. I'm in a spacesuit.
That's like constantly being 15 meters or 50 feet below the ocean.
Only 15 meters? I mean, for sure that's not comfortable, but that's fine. I'm fine. You'd be fine.
Well, that's not the dangerous part. Titan's atmosphere is 95% nitrogen and 5% methane, which means any exposure to oxygen and the smallest hint of a spark will result in a catastrophic explosion.
Great, then I'll just keep my oxygen tanks nice and close, and we'll not have any problems.
Titan is the only other body in the solar system that has liquid lakes on its surface. It also has a weather cycle similar to Earth's, but instead of water, it's methane. The temperature on this moon is so cold that liquid methane rains down and forms these lakes.
Surface temperature reading at minus 179.15 degrees Celsius.
Rise and grind, chase heads. Time for the cold plunge.
Liquid methane is about half the density of water, so if you get in, well, you're never getting out. Chase literally sank so fast that he didn't even cause a splash. And in case you feel bad that he's drowning, there's really no need to worry. In the Titan lakes, you wouldn't die of drowning. You'd die of instant freezing. The liquid methane is about minus 180 degrees Celsius. So cold that your lungs and your entire body would freeze within seconds.
I just drowned. I just need a little extra air. Okay, Chase just needs a little extra air. That's all. That's all I need.
Looks like Chase forgot about the oxygen and methane thing. Can't say I didn't warn him. Well, Titan is a fun rock. My favorite moon in the entire solar system. I'll give it a 9 out of 10. Only taking off 1 point because it killed Chase.
Twice.
Yeah, but who's counting? While we're around Saturn, let's check out another one of its treacherously icy moons, Enceladus.
You know what Saturn is missing, low-key? Like, the tropics. Let's get a palm tree around here, like a pina colada. Just something to take the edge off. This place is harsh.
Yeah, you tell Saturn to start working on that. Enceladus is even colder than Titan at a temperature of minus 201 degrees Celsius. But this moon is tiny. Titan, the moon Chase just died on, is larger than Earth's moon and even larger than Mercury. Now, Enceladus is only 504 kilometers in diameter. That's 315 miles, 10 times smaller than Titan.
Aw, so cute.
Well, its small size means it's incredibly vulnerable to the gravitational forces of the massive solar bodies around it. That means that Enceladus's geological activity is violent and intense.
Classic Peter. Always making the little guy seem evil and malevolent.
Malevolent.
Malevolent. Whatever. Whoa.
Gravity reading 0.113 meters per second squared.
That's like 100 times less than Earth. Odie.
Enceladus is so small that any seismic activity is felt everywhere on this moon. These movements are so powerful that entire chunks of ice tear right off and fly out into space. Or trigger moonquakes so powerful that they bury our brave space explorer, leaving his body to be taken by the
I can't
ice.
believe I survived that. Take that, Peter. Whose legs are those? Aw, man. Help.
Underneath all that ice, or where Chase's body was just buried, is a hidden ocean.
Rico, how thick is this ice shell here?
In the South Polar region, the ice shell is about 1.194 kilometers.
Yo, that's easy work. I'll find the ocean down here in no time. Wait, we are at the South Pole, right? Okay, good. Ah, my handies.
Enceladus is constantly shooting ice into Saturn's E-ring from cracks in the moon's crust and geyser-like jets. But closer to the surface, these eruptions also contain a lot of gas, full of chemical compounds buried deep in the core. And just like the volcanoes on Earth, these emissions are completely toxic. We're talking methane, nitrogen gas, and carbon monoxide. And if that doesn't get you, scientists have also discovered hydrogen cyanide. Yeah, you heard me right, cyanide. That little pill that spies take to die and avoid interrogation? Now, while hydrogen cyanide is a good indicator that the moon contains all the chemicals needed to create life, it's a pretty bad indicator of life when it's been shot straight into your face. With a blast of hydrogen cyanide like that, you're dead within a minute. respiratory failure, seizure, dead. That was cool. Too bad Chase died before getting to the underground ocean. I'll give this moon 4 out of 10. Saturn has so many moons that it would be impossible to die on all of them. But there is one more we should visit.
What? We? Do not act like you are also dying on all of these planets, Peter. It is me, and just me.
Fair enough.
Rico, get me a mimosa.
The last of Saturn's moons that Chase will die on is Mimas, a real-life Death Star.
Oh man, I am into this. This is like Comic-Con.
Mimas is home to the Herschel crater, a giant impact crater that defaces 1/3 of the entire moon. It's 130 kilometers across and 10 kilometers deep.
Oh man, I have got to see that up close. Punch it, Rico. No, Obi-Wan. You are my father.
Something's telling me he hasn't actually seen the movies.
Yes, let the hate flow through you.
Well, Mimas has a gravity of only 0.044 meters per second squared, so with the depth of that crater, he'll be falling for about 9 minutes. Even though he's falling so slowly to start, he will accelerate to 129 kilometers per hour by the time he hits the bottom. Meh. That's a lot of anticipation for one splat at the bottom of a crater. Let's give this tiny little moon of Saturn a 3 out of 10. Now, if you thought Mimas was tiny, well, wait until you see our next moon, Phobos. It's only 22 kilometers in diameter, but that doesn't make it any less dangerous.
Yeah, tiny things can be scary. Just think about Charlie. That guy, he's up to no good still.
Phobos is actually Mars's biggest moon. Its other moon, Deimos, is half its size. And with the small size comes very weak gravity.
Gravity reading 0.1% of Earth's gravity.
This is so fun! Do we have a basketball hoop? Oh man. I could totally dunk in this gravity. I mean, I can totally normally dunk. It's just I would be able to dunk like better and stuff. Whatever. Oh my god, I have an epic idea. Rico, keep my spot warm. Oh. Oh. Oh, impact crater, yes! Watch this. Rico, punch it. Oh no, not again!
Because the gravity is so weak here, the escape velocity is only 41 kilometers per hour. That's 25 miles per hour. Chase drove too fast and, well, he escaped the gravitational pull of Phobos. He's not coming back down.
What? Huh?
Oxygen levels, 10%.
Okay, well, at least I'll die how I lived. Fast and furiously.
Oxygen levels, 2%.
Yeah, speaking of dying, Phobos is just as doomed as Chase. This moon is orbiting ever so slightly closer to Mars. It's slow crashing into the red planet at a speed of 2 centimeters a year. If you visited Phobos some 50 million years from now, you'd see it slowly break apart. Yeah, Phobos just reached Mars's Roche limit. That's the point in the orbit where Phobos is so close that the gravity of Mars would tear it apart. Well, Phobos was fun. I'll give it an 8 out of 10. It's fun, but still a little deadly. Triton, the coldest place in our entire solar system. This moon receives 900 times less sunlight than Earth, and any light that it does receive is reflected right back off its icy surface. This is no place to get warm and cozy.
Rico, temperature?
Minus 232.35 degrees Celsius.
Oh, that's not that bad.
It's so cold that I'm not even sure we've equipped Chase with a suit strong enough to bear it. Triton's atmosphere is almost completely nitrogen, which has a freezing point of minus 210 degrees Celsius. At these temperatures, even the nitrogen in Triton's thin atmosphere can start freezing onto any surface, like your face. Chase? Yeah, his lungs burned from the freezing air. His blood literally froze over, and every single internal system shut down. On Triton, you'd be dead within minutes. But luckily for Chase, at this point, he's so numb that he can't really feel anything. Triton, not as fun as Phobos. It's just unbelievably freezing. It has cryovolcanoes, but you'd need to be able to survive a little bit longer to check them out. I'll give Triton a 1 out of 10. Hey, shouldn't I have a helmet on these moons? No? All right, now we're going into a stretch of Jupiter's moons. Each of these lunar bodies are incredibly distinct, so we should be seeing a pretty awesome range of deaths. Starting with Ganymede, the largest moon in the entire solar system. With a diameter of 5,270 kilometers, this moon is even bigger than Mercury. And not only is it huge, but it has a core of metallic iron, making it the only known moon to have its own magnetosphere. And because its magnetosphere is constantly interacting with Jupiter's, the moon has intense auroras, just like Earth.
I've never seen anything like this. Oh, except that time on Neptune when I saw something that was exactly like this.
Guys, I was just in Neptune's planetary fireworks. My life is awesome.
Except Neptune's auroras beat Ganymede's auroras hands down. These are pretty awful, actually.
Warning. Electromagnetic disruption detected.
Here's the thing. Jupiter is enormous, but it's not the largest object in our solar system. Its magnetosphere is. Jupiter's magnetosphere is so intense and so gigantic that Ganymede is actually orbiting inside of it. Because Ganymede has its own magnetosphere, the interactions between the two fields can be extremely destructive. But that's not even the biggest problem. Jupiter's magnetosphere is filled with lethal radiation, so orbiting near Jupiter is like floating next to the exposed core of a nuclear reactor. And Chase's suit is, well, electronically delicate.
Life support systems failing. Decompressing.
That fast of a decompression means all the oxygen in Chase's body just exploded out of his lungs and formed bubbles in his bloodstream, pretty much boiling his blood and causing instant death. At least the last thing he saw this time was really, truly beautiful. I'll give this moon 7 out of 10. What, you can't see the auroras from Ganymede? Oh well, that's a bummer. It turns out auroras on this moon are not like auroras on Earth. You can't see them with your naked eye, only with space telescopes that read ultraviolet light. So let's make that a 1 out of 10 for Ganymede. Callisto. This is the most cratered surface in the entire solar system. It stands out because there's almost no geological activity on this moon. Unlike many other moons and planets where volcanic eruptions, shifting tectonic plates, or other forces reshape the surface over time, Callisto's crust has remained largely unchanged for billions of years.
That's kind of like Vegas. What happens on Callisto stays on Callisto. We should open a space casino. So fitting.
Peter has filed this as bad ideas, Chase.
Bad ideas? Listen to this one, Peter. Raw sewage in a can. People are gonna eat that up. Not literally, hopefully.
Anyways, Callisto is constantly pummeled with asteroids, and with barely any atmosphere, there's nothing to stop even tiny space rocks from causing major damage.
I hate when planets and moons don't have an atmosphere. It's always so
Without an atmosphere, that meteorite can hit you at a speed of 50,000 kilometers per hour. Faster and more fatal than a bullet. And with the damage to your spacesuit, your entire body would rupture from the pressure change and then instantly freeze in this minus 140 degrees Celsius temperature. Not a pretty sight. I expected more of Callisto. I'll rate this moon a 2 out of 10. Talk about ugly sights. We finally arrived at Io. This is a true hellscape of toxic gas, volcanic eruptions all around, and lakes of molten lava.
Wait, that was Callisto? I've been there before. Why didn't you say something, Rico? No more Jupiter. I want to go see Pluto next. Listen, if you sickos really want to see me get all up in Jupiter's other moons like Io and Europa, then go check out the video I already did. I'm not doing all this again, Peter. Next moon, next moon. Alright, so this moon was actually my request. Karen is the biggest moon of Pluto. And fun fact, she wants a word with the manager. Pluto is small, so obviously all of its moons are pretty small, which means weak gravity. I'm so bringing out the rover for this one. Woo! Oh, finally. The escape velocity here is 2,100 kilometers an hour, so, yeah. Chase is not getting lost in space this time. Ugh! I love this moon! Oh man, gravity's so weak to make my jumps epic, but not so weak as I'll fly away. Oh man, I think I'm gonna move here. Wonder if there's any condos for sale.
Karen is marked with these mountains and canyons, all the features that suggest unstable geological activity. And that's because once Karen was active, geologically. Billions of years ago, Karen's internal heat was cracking its icy crust, forming massive tectonic rifts and even fueling cryovolcanic eruptions. But that era is long gone. With no tidal heating from Pluto, Karen cooled down and became a frozen, quiet world. We'll no longer need to see the manager.
I'm just gonna take a quick look around and then maybe take my rover out for one more rip, do a couple donuts in the parking lot, and then I'll be good to go. Yeah, okay, I'm good, let's go. Rico, can you, put it in reverse or something? Rico? Oh boy. Oh no. Oh boy.
I think we should spend more time on Karen. What do you think? I'll give it a 6 out of 10 for now, but I'm sure Chase will be back. One day. The moon. Finally, something close to home. Even though you see Earth's moon every night, it doesn't make it a safe place to visit.
Hey, you guys! That's you guys over there! If I throw this hard enough, I bet you I could hit you, Peter. You can't stay inside forever. Is that bad?
Yeah, those measly rocks will burn up in the atmosphere and I'll be fine. Chase, on the other hand, not fine. The moon is exposed to constant micrometeorite impacts and intense solar wind. And that means that moon dust is electrostatically charged and very, very small. So small that its particles can enter straight through that crack in Chase's helmet, into his airways and right into his bloodstream. Chase is basically inhaling tiny shards of glass that are ripping their way through his lungs. With all that internal bleeding, he'll be drowning in his own blood very soon.
Oh, God. Oh, I should have thrown the rock when I had the chance.
A meteor shower? Space debris? No, it's something much, much worse. Our nearest neighbor is a full moon no more. The moon exploded and splintered into millions of fragments. Enormous lunar rocks are hurtling toward Earth. Could this wipe us off the face of the planet? How could the moon explode in the first place? And if we do survive, how would losing the moon change life as we know it? This is What If? And here's what would happen if the moon exploded. Okay, so how on earth did the moon blow up? A blast mining operation gone wrong? A nuclear blast? A collision with a rogue planet? Whatever caused this catastrophe, you'd have to be packing some serious firepower to blow up the moon.
Guns. Lots of guns.
The largest nuclear bomb ever built, the Tsar Bomba, had the energy of over 57 million tons of TNT. Think that's strong enough? It's just a drop in the ocean compared to the amount of force you'd need to blow up the moon. You'd need the power of over 600 billion Tsar Bombas to destroy the moon. With anything less than that, the moon would just crack into pieces, and its gravity would pull it back together again. But if someone, or something, managed to explode the moon, it would spell bad news for us. The moon debris would scatter across the solar system, some into the abyss of outer space, and some headed straight for Earth. Earth's gravitational pull would immediately start to attract the moon rocks. As the moon's remains start to pick up speed, they would come crashing down into the atmosphere. Luckily, most of the smaller debris would burn up before it reaches us. Any larger pieces that got through would be traveling much slower than a similar-sized asteroid. The damage they'd cause wouldn't amount to much. But is it just me, or is it getting a little hot in here? The moon chunks aren't causing much damage, but the endless barrage of debris on our atmosphere would start to heat up the Earth. The whole world would start to get hotter and hotter, eventually getting to the point of incinerating all life. Talk about a bad way to go. Oh, and if you're thinking about trying to evacuate Earth, you better do it as soon as possible. The moon debris, combined with all the satellites it would destroy in space, would make any trip out nearly impossible. But what if you did manage to get out of Dodge or hunker down in the deepest parts of the Earth? What would life be like in the aftermath? Well, for some of us, it wouldn't get any cooler. The moon helps stabilize the Earth's axial tilt. It's what gives us seasons. With a new tilt, some parts of the Earth could be constantly exposed to the sun. In the worst case, the polar regions could start rapidly melting, raising sea levels and drowning out parts of the world. As the debris settles, the skies could look a little different. The remaining moon rock might cluster around the Earth, forming a giant ring like Saturn. But don't stop and stare too long. Every once in a while, some of the debris could rain down onto the Earth. Over billions of years, the moon's gravitational pull slowed down the Earth's rotation, giving us our 24-hour days. Without the moon, the Earth would start to rotate faster and faster. We'd have shorter days and stronger winds. Birds and insects would have a tough time surviving the harsh winds. Not only that, ocean tides would start to die down into tiny little waves. The moon's gravity helps create tides on Earth. Bummed out that you can't rip some gnarly waves anymore? Well, dude, there'll be a much bigger problem. It would wipe out all of the sea creatures that rely on the tides and ocean currents for survival. Our whole world would be literally flipped upside down.
the Earth would burn up, our days would be shorter, and the moon wouldn't be there to light up the night sky. Imagine if one day you looked up into the night sky and saw Mars or Saturn where the moon was supposed to be. That would sure turn our Earth into an alien world. And not just because of the new view. How would replacing the moon change the Earth's orbit? What planet could we safely replace our moon with? And what planet would be the most disastrous? This is What If, and here's what would happen if another planet replaced our moon. We can thank the moon for predictable weather, ocean currents, and the circulation of important nutrients. The moon also helps stabilize the Earth's tilt. Take away the moon, and the Earth would go wobbling all over the place, and it would cause what I can only describe as climate change on steroids. But we wouldn't just let the moon take a day off. We would find it a replacement from another part of our solar system. So, what would happen if we swapped our moon with a planet that is 41 times its size? Before we get to that dramatic part, let's talk about Pluto. Pluto wouldn't look much different than our current moon. It would be smaller though, and this wouldn't be good for Earth. That's because Pluto's gravitational pull would be weaker than that of the moon. Earth would begin wobbling all over the place, and it would result in dramatic climate change. All sorts of natural disasters ruining your day. The moon's gravitational pull is responsible for our daily ocean tides. Because Pluto is smaller than our moon, our ocean tides would become weaker. This would devastate important ecosystems. Well, how about
A planet that is slightly larger than our moon. Mercury would look exactly like our moon, with its dark gray surface and asteroid craters. And it's only 1.5 times the size, so its impact on our tidal systems and climate wouldn't be as disastrous. Out of all the planets in our solar system, Mercury would be the safest one to replace our moon. But I can't say that about Mars. Having the red planet in our night sky would be quite a sight. All the iron oxide on its surface would glow red. No more white moonlight shining through your window at night. Instead, everything would be bathed in an eerie red. Mars's stronger gravitational pull would make tsunamis smaller, but it would make normal waves massive. And because Mars would create stronger tidal forces, Earth's rotation would slow down. The days on Earth would become longer. I hope we'd still keep a 40-hour work week, because a 16-hour workday doesn't sound that great. Moving on. With Venus in our night sky, we might never experience darkness. Venus is the brightest planet in our solar system. It would reflect 60% more light than the moon. And because it's 3.5 times the size of the moon, it would force the Earth into a binary system. Earth and Venus would rotate each other. It would be beautiful and disastrous. Simulations of a binary system usually end up with planets colliding or merging. Neptune and Uranus are both ice giants and are similar in size. A huge portion of our sky would be taken up with a blue-green planet. Only Uranus would also stink horribly. No wonder this fart-smelling planet got such a name. Since both Uranus and Neptune are 14 to 15 times the size of the Moon, their impact on Earth's rotation and tidal systems would be drastic. Beach houses would have to be built up on cliffs, far enough away from the reach of enormous waves. Now, seeing Saturn up in the night sky has to be my favorite. Its pale yellow color and ring system would be stunning, but there would be some complications. Because Saturn is so large, the Earth would quickly become its moon. And if Earth orbited around Saturn, it simply wouldn't be the Earth as we know today. Finally, moving on to the big guy,
Jupiter. At 41 times the size of the Moon, you wouldn't even be able to see the north and south poles of the gas giant. Similar to the deal with Saturn, Earth would become Jupiter's moon. Only it would get worse. Because Jupiter is so massive, the side of the Earth that's closest to Jupiter would experience a stronger gravitational pull than the opposite side. This would distort the shape of the Earth. All this pulling apart would create frequent volcanic eruptions and violent earthquakes. Jupiter's gravitational pull would tear the Earth apart. So enjoy the view while it lasts. The Moon's surface is made up of long-dead volcanoes and impact craters from asteroids. But have you ever wondered what might be inside it? We could find out one day by digging a tunnel through the Moon. How long would this take? What mysteries would we find inside? And how would gravity affect our dig? This is What If, and here's what would happen if we dug a tunnel through the Moon. Unlike the Earth's layers, we don't know much about what's inside our moon. But we do know to get through it, you'd need to dig over 3,000 kilometers. And with today's technology, doing something like this would take about 1,300 years. But what if we managed to fast forward this with more advanced technology? What would happen then? To start our journey through the Moon, we'd first want to choose an area that would give us a head start. The best choice here would be the South Pole Aitken Basin. This is a massive basin that's 8 kilometers deep. For comparison, the deepest hole on Earth is 12.2 kilometers, so this would save us a lot of time. Now it's time to start digging. The first layer you'd need to worry about would be the Moon's regolith, also known as the Moon's outer crust. It may not seem like it at first, but this layer is surprisingly dangerous. Regolith is billions of years of crushed asteroids and moon dust. It's razor sharp and very fine, and can easily get into your suit and your drill, which will wear them down over time. And make sure you don't accidentally inhale any of this stuff, as it can cause lung cancer. You'll be digging through the regolith layer for up to 15 meters until you reach the lunar crust. This layer is made up of bedrock, and it's where you might make some money, since rocks in the crust contain lots of titanium and aluminum. You'll also be able to find iron, calcium, and magnesium. We could either bring these back to Earth or use them to help us colonize the Moon. This layer is about 100 kilometers deep. Once you're through it, you'll then have to deal with the lithosphere. This layer used to be magma that would supply the Moon's volcanoes, but thankfully it's cooled and is now solid. What we'd be less thankful for is that this layer is nearly 1,000 kilometers deep, so you'd keep drilling and drilling and drilling and drilling until you finally reach the asthenosphere. What's different here is that this layer is made up of molten lava. at this point, your journey would definitely be over, as you'll be facing temperatures of up to 1,500 degrees. But we'll give you a special suit to help you survive this. Oh, and a special drill, too. Now, you wouldn't be drilling at this point. Instead, you'd be trying to swim your way through this magma. And as you get past this, you'll be met with another liquid. But this time, it will be liquid iron, which is the outer layer of the moon's core. Its radius is roughly 330 kilometers, so let's hope your suit can still withstand the immense heat. And as you drill your way through these thousands of kilometers, you'll notice that the gravity has been changing. As you reach the center of the moon, the gravity will reach zero and you'll be completely weightless, floating in the moon's inner core made of solid iron. So, now that you've reached the center, it's time to make your way back out. Through the outer core, out through the asthenosphere, then the lithosphere, inner crust, and finally the regolith layer. And drilling through wouldn't take as long as it did the first time. That's because the inner crust is about 40 kilometers thinner on this side of the moon, which is the side that faces the Earth. Digging through the moon has some benefits, but overall it wouldn't be worth it. After all, this project would take 1,300 years, and who wants to wait that long? All right, I think it's time for a change-up. Let's do a little spring cleaning and redecorate our solar system. Now, I know you're a big fan of the moon, but it's so last season. Let's get something fresh, something snazzier. How about Europa?
That I love. I absolutely love.
I know. The moon is a classic, but Europa could be a heck of an upgrade. Oh, and before you ask, the trade was mutual. The moon is just fine. So we'll just moon swap with Jupiter. What's the worst that can happen? What secrets does Europa have in store for us? Would Europa be the perfect addition to our night sky? Or did we mess up really badly? This is What If, and here's what would happen if Europa was Earth's moon. Europa is one of Jupiter's 79 moons, so I don't think they'll mind if we borrow it. Covered by a thick layer of ice, with water beneath its surface, Europa is the 6th largest moon in our solar system. Because of its icy surface, Europa reflects a lot of sunlight, making it very, very bright. About 5.5 times brighter than our moon, to be exact. And to sweeten the deal, Europa has 3 essentials for supporting life, namely water, chemistry, and energy. Europa's water dissolves nutrients so they can be eaten by organisms. This means that our new moon can be used to transport chemicals within living cells. Plus, if we moved Europa to our current moon's spot, it would then be millions of kilometers closer to the sun. Sunlight might just be the one missing ingredient that's been impeding any life there from developing further. So, if we relocate Europa, we may eventually have some new neighbors. So, are you sold yet? Huh? You're not? Well, I've already filled out the real estate paperwork, so we're just gonna go ahead and do the swap. So, imagine looking up at the night sky and seeing, well, everything. Europa would light up the night sky and be a breathtaking sight. To make things even better, there would be no negative consequences at all. Okay, you copy. Look, I'm really not good with this whole real estate thing, so I'm gonna come clean with you. The first inconvenience you're going to have is trouble sleeping. Imagine a floodlight coming through your bedroom window. Maybe you could just get some new blinds? And it won't just be you who's having a hard time adjusting. it's going to affect wildlife as well. For example, a lot of rodents hide when the moonlight is strong to avoid becoming dinner for predators. But with a strong, continuous moonlight, they'll eventually be forced to go outside and into danger. This means the rodent population will decrease rapidly, and that would affect the entire animal food chain. Next, Europa will shake things up, but not in a good way. The mass of our moon is 1.5 times greater than that of Europa. This means that Europa would have a much weaker gravitational effect on the Earth. The tides of our oceans will become much smaller. They may stop removing pollutants and circulating nutrients. You know, stuff that the ocean plants and animals need to survive. If the tides are out of whack, it could have a devastating effect on ecosystems and lead to mass extinctions. Okay, well, it can't get any worse, can it? Look, don't be mad, but we may have messed up our entire planet. But just look at how pretty the moon is. See? Yeah, just take it in and... You're not buying it, are you? Our moon is responsible for stabilizing the Earth's axis. Without the moon's pull, this new gravitational shift will start affecting our planet's seasons and climate. We could be looking at a future where parts of Earth hardly ever see the sun and others never get a break from the sun. This would affect everything, and I mean everything. If our axis became tilted too much, we could be looking at another ice age. Thankfully, this process would be slow, so there would be time to prepare. The problem is, we're not sure we have what it takes. I mean, look at global warming. Just a few degrees difference can cause entire ecosystems to become disturbed or wiped out, and we've barely scratched the surface of solving that problem. So maybe we should give our real moon a call and see if it'll take us back. We were just so excited about something new and sexy that we took our moon for granted. I miss you, moon. The good news is, there are no real-world plans to move our moon. Swapping our moon with Europa could lead to some beautiful scenery, but at the cost of catastrophic consequences for Earth. The moon has been our friendly neighbor in the sky for billions of years. It's guided us home, kept us on time, protected us, propelled us into space, and has even launched dance crazes. It's hard to fathom what we would do without it, but for the sake of science, let's try to envision a moonless world. What would happen to Earth? Would humans still exist? And what would life be like? This is What If, and here's what would happen if the moon had never formed. So, how exactly did we get a moon in the first place? Scientists believe it started off with a splash. The giant impact hypothesis, also known as the Big Splash, theorizes that a Mars-sized celestial object named Theia came crashing into Earth 4.5 billion years ago, tossing vaporized particles of Earth's crust into space. At this point, Earth was still a baby, only 30 to 50 million years old and not much more than molten lava. Some scientists call this early Earth Gaia. Over time, the debris of Gaia and Theia joined together in a dance with Earth's gravity and formed the moon we know and love today. And lucky for us, our moon's orbit and gravitational pull tilt the Earth 23.4 degrees, creating tidal bulges that help slow the rotation of our planet just enough for life to safely exist. Or so we think. Despite a popular theory, having a moon is no longer a requirement for life to exist. So, could we really exist without our moon? How would we survive? Well, with a little gravitational help from our friends the Sun and Jupiter, life could still have evolved without a moon. But how? Well, with no moon to keep the Earth on an even keel, things might get a little wobbly. We'd have to put up with some extreme weather, our concept of time and seasons would drastically change, and we may evolve to look short and stubby. You can learn more about this in our other video, What If We Lost the Moon? There is, however, another hypothesis. In a study conducted at the NASA Ames Research Center in 2011, scientists performed complex simulations in which the Earth didn't have its moon and measured the effects on Earth's spin over time. The results were shocking. They discovered that the Earth's wobble would eventually stabilize due to Jupiter's immense gravitational pull, deviating no more than 10 degrees off its axis. Thanks, Jupiter! Scientists have also found that the Earth might have spun backward before the moon formed. This would mean that the sun would rise in the west and set in the east. Feeling dizzy yet? Our sky would be a lot darker than usual without the moon to reflect the light of the sun, but that would be perfect for stargazing. Mind you, we'd still have a little bit of light from Venus to help light our way in the dark, but the moon is 2,000 times brighter. At the very least, we wouldn't have to put up with wolves keeping us awake at night. Farmers would have to be careful with their crops without a harvest moon, and women's menstrual cycles would change. Despite these conditions, there's a lot more to our moon than just pure science. Without it, our whole idea of the universe could change dramatically, slowing our progress as a species. If it weren't for Italian astronomer Galileo's discovery of the moon's spherical shape in 1609, we'd probably still think the Earth was the center of the universe.
Houston, we have a problem.
An idea proposed by Aristotle in 284 BCE that was widely accepted for over 1,500 years. Our moon was instrumental in launching the space race, which propelled humans to the stars. In the words of Neil Armstrong, going to the moon was
one small step for man,
one giant leap for mankind. What if our moon had a twin? Seeing not just one, but two of these satellites in the night sky might be spectacular. But how would this second moon affect the ocean tides? Would months on Earth become longer or shorter? And would these two satellites inevitably collide to cause a massive explosion? This is What If. And here's what would happen if the Earth had two moons. Despite what you think, the Earth isn't really the monogamous type. Along with the moon, Earth has another moon-like companion, a small asteroid wandering around it. But it's so far and so small that it can only be considered a quasi-satellite to our planet. In our scenario, we're talking two real moons, just like the Earth had during its formative period. Yep, we likely had two satellites once. Both of them formed when a Mars-sized protoplanet slammed into Earth and shattered into small pieces. So what exactly would happen if the Earth had another moon parked in orbit around it? Let's assume our second moon would be around 1,000 kilometers wide and about 1/30th the mass of our current moon. It would be about the same distance from Earth too, just like the sister satellite our moon had 4.5 billion years ago. Would we see this double moon from Earth? Absolutely. The second moon would just appear about 3 times smaller. Still, it would be a spectacular view. Along with two moons would come some big tides. The newly captured moon would have a much smaller tidal effect than that of our moon, but the tidal force from both satellites combined would make waves, literally. Although those waves would be bigger, they wouldn't be devastatingly big. In the end, I think surfers will be pretty happy. The second moon might stay in Earth's orbit for tens of millions of years, until eventually, as the moon retreated further from the Earth, it would destabilize the other moon's orbit. Then, just like they did over 4 billion years ago, the two satellites would collide in slow motion. Because they'd be moving slowly towards each other, the debris from the collision wouldn't shower back on Earth. The small moon would splatter itself across our moon as an extra layer of solid crust. The new mountains of crushed rock visible from the near side of our moon would be the only reminders of its existence. Now, what if the second satellite happened to be the same size as the moon and orbited the Earth at half the lunar distance? This time, things wouldn't be so pretty. The second moon alone would produce tides 8 times greater than what we see right now. That would force people away from the coastal areas because the difference between high and low tides would now reach 300 meters. Constant tidal flooding would shrink the habitable area on Earth, but once we adapted to this new world, we'd get to enjoy a beautiful double moon. This time, the second satellite would look bigger from Earth due to its closer orbit. The moons would also have different phases, which means we'd have to come up with another way to measure a month. And then there's some worse news. The 2 moons would be slowly moving away from Earth and eventually would crash into each other. This collision would send debris back to Earth. It would be a shower of meteorites of epic proportion, and it could wipe us out entirely. Whatever debris didn't fall to Earth would form yet another new moon in Earth's orbit. Imagine living on the moon. You'd have the best view of Earth. You'd enjoy bouncing around in zero gravity and living your life as an astronaut explorer. Doesn't that sound nice? Except living on the moon won't be like this at all. So, what would it be like to actually live on the moon? Who will establish a base first? And why would moon dust be your biggest problem? This is What If, and here's what would happen if we settled on the moon. Let's make this clear. Just like America did in 1969, humans will land on the moon again in the next decade. Only this time, it's expected to be more permanent. What's less clear is exactly which country will be the first to land and establish a base. China, the USA, Russia, and India are all making strong efforts to get there. But there are also private companies, including SpaceX and Blue Origin, that have a lot more money to spend on going to the moon. But wait, why exactly are these companies doing this in the first place? Apart from exploring the galaxy and breaking new ground, there's another huge reason these groups all want to be the first to create a base on the moon. And that reason is money. The moon is chock full of different resources. It has gold, silver, and titanium in it. The idea here is to mine these precious resources and send them back to Earth. Another resource the moon has is helium-3. It's incredibly rare here on Earth, but not on the moon. That's because the moon doesn't have an atmosphere, and helium-3 comes from the sun's radiation. Over billions of years, the moon has been absorbing this chemical, and lucky for us, it can be used for energy. Helium-3 is so powerful that just 100 kilograms of it could power the city of Dallas, Texas for an entire year. Oh, and it's also worth a cool $40,000 for just 28 grams of the stuff. With these resources holding incredible value, it's no secret these countries and companies want to be the first to establish a base. But even if they do, they won't really own it. Back in 1967, the United Nations decided that no one can really own space. This has the potential to cause huge tensions between various nations, possibly leading to war. But enough about all that drama. You are on the moon. So, how exactly are you going to live here? Assuming we get to the moon in one piece, which is already an incredibly difficult task on its own, you'll then have to worry about establishing a base. Experts suggest that we live on the moon's south pole, as it gets the most consistent amount of sunlight. There are also massive fields of ice that we'll be able to harvest. Some other places on the moon don't get any sunlight for nearly a month at a time. Luckily, you'll have robots to help you establish a base. There are many different ways they'll be able to help. One includes using moon soil to construct bricks and configuring them in a dome-like fashion, sort of like a moon glue. This would make traveling to the moon a lot cheaper, as we wouldn't have to bring everything from Earth to make our base. But don't expect this base to be glamorous. It'll most likely be several meters underground to protect you from the sun's radiation. And as for what you'll eat, well, it'll be your standard dry astronaut food. The good news is that you should be able to grow some carrots and tomatoes. A 2014 Dutch study found that it's possible using soil on the moon. And what would you drink? Unfortunately, quite a lot of it will be your recycled pee, as drinking water won't be available on the moon, and it would be too heavy to ship there. Another thing you'll need to seriously worry about is moon dust. This magnetic dust gets everywhere. It'll get on your suit and even on your skin. Previous astronauts have had allergic reactions to it. It's also slightly sharp, so accidentally swallowing any would be a huge problem. But it's not just humans who need to worry about moon dust. It can get into machines as well, causing them to overheat. Before we settle on the moon, this is one massive problem we'll need to solve. All these issues beg the question, would you ever really want to be the first to settle on the moon? You'd most likely spend your time mining and just surviving, with little time to run around in low gravity. And besides, we all know that going here is just our first baby step to get to Mars. So maybe you should just wait for that.
What if the moon suddenly began getting closer to Earth, to the point where it was on a collision course with our planet? Would Earth survive the crash? Or would a crash even happen? Would the moon get torn up by Earth's gravity? What would this crumbled up moon look like from Earth? This is What If, and here's what would happen if the moon fell to Earth. The moon is Earth's only natural satellite, and the largest object to brighten our night sky. It's the first and only place beyond Earth where humans have set foot. The moon's gravitational pull causes tides on Earth, tides that might have been the encouragement for life in our oceans to move on land. This pull also keeps Earth from wobbling on its axis, making our climate relatively stable. In short, the moon makes Earth a more livable place. So, what if it suddenly sped up and started driving in Earth's direction? The moon's plan to destroy Earth by bumping into it would break into pieces the moment it reaches the Roche limit. The moon itself would shatter, never making it to Earth's surface. And that's going to look very impressive. But wait, what is this Roche limit? In celestial mechanics, it's the point at which the gravity holding a satellite together is weaker than the tidal forces trying to pull it apart. In other words, the moon can only get as close as 18,470 kilometers away from our planet before boom, the tidal forces would tear it apart. All of the footprints and flags we've left on the moon, all of its craters and valleys would scatter to form a breathtaking ring of debris above Earth's equator, 37,000 kilometers in diameter, making Earth the second planet in the solar system, after Saturn, to have this striking ring of beauty. The difference being that our rings wouldn't last long. The chunks of our former satellite, the moon, would rain down on Earth. It would be as if hundreds of thousands of asteroids were falling down on us and wiping out entire cities in the process. Once the moon began its trajectory towards the planet, it would increase the tidal impact it has on us. By the time it hit the Roche limit, it would be causing tides as high as 7,600 meters. Our world would be devastated by an army of tsunamis, 10 times a day. But for a short time, hardcore surfers would enjoy riding some tasty waves. On the other hand, this might be a solution to global warming. With the moon coming closer and closer, Earth's rotation would speed up. Our days would become shorter and shorter. Global temperatures would go down and no one would worry about climate change anymore. Unless asteroids burned the Earth to a crisp, then there would be no one to worry about anything. I really wouldn't worry about it anyway. In fact, the moon is drifting away from us at a rate of 4 centimeters per year. So it's unlikely we'll get to see those pretty Saturn-like rings here on Earth.
What if we humans could live somewhere outside of Earth? Say the moon. Obviously, we can't just pack our stuff and move there today, but what if we terraformed it, reshaped it into Earth's image? How long would it take us to turn our natural satellite into a habitable place? What would this Earth-moon look like? Would this even be possible? This is What If, and here's what would happen if we terraformed the moon. Wondering why we chose the moon and not Mars? With water ice buried beneath its surface, the red planet seems to be the best candidate to serve as our second Earth. But with zero experience terraforming, we should consider colonizing our natural satellite first. It gets twice as much sunlight as Mars, and it's just a 3-day trip from us.
In short, it would take us less time and money to construct a decent Earth on our moon. So, how exactly do we engineer a habitable planet? Just to be clear, we're not talking about building a permanent moon base. We'd go nuts and actually transform the moon into an Earth, just a smaller one. For starters, we'd need to build an atmosphere. And here's the fun part. To do that, we'd need to bombard our moon with 100 water ice comets, asteroids. We'd find them flying all around the Earth. These comets would crash into the moon's surface. They'd fill the moon's plains with water and disperse carbon dioxide along with water vapor and a little bit of ammonia and methane. All these gases would gather near the surface, creating an atmosphere. The newly formed seas would reflect much more sunlight, making the moon appear 5 times brighter when seen from Earth. These asteroids would also give the moon a momentum. They'd make our satellite spin close to an Earth-like cycle. The more comets we batter into the moon, the faster it would rotate. A lunar day would drop down from an incredible 28 Earth days to just 60 hours. Since our satellite wouldn't rotate on its axis at the same rate it orbits the Earth anymore, it would no longer be tidally locked to our planet. For Earthers, this would mean we'd be able to see the dark side of the moon, although it wouldn't be dark. But how do we save the newly built lunar atmosphere from being stripped away by solar winds? We'd have a couple of options. The first one is easy. Moon's own rotation would generate a dynamo effect. That dynamo could awaken the moon's once active magnetic field that would keep the atmosphere in place. If that doesn't work out, we'd have to place a gigantic shield in orbit. That shield would work as an artificial bow shock, making up for a missing magnetic field. When that's all sorted, we'd bring in genetically engineered plants, suitable for growing on the moon's stony ground. We'd also drop some algae that would release oxygen into the air. That would be the start of life on the moon. Finally, after many decades of hard and costly work, we'd send the first human colony to settle down on the first man-made planet. The terraformed moon would get very warm from greenhouse effects. It would be mostly cloudy too, and with tides as high as 20 meters, surfers might want to make the trip. Living on the moon would be just like living in Florida, but with 1/6 of the Earth's gravity. The moon settlers would be able to jump as high as 3 meters off the ground, remaining in the air for 4 seconds. And if they were really fit and full of stamina, they'd be able to run across the moon's lake. The moon is a giant rock that lights up our night and can even change colors. So what would we do without it? Would we all need night vision goggles? How would it affect the ocean tides, our seasons, or our sleep cycles? Or would the consequences be far more dramatic? This is What If, and here's what would happen if we suddenly had no moon. As the closest celestial body to our planet, the moon exerts a gravitational pull that governs much of what happens here on Earth. Take the sea, for example. If you like surfing, you can thank the moon. When the moon's gravitational pull tugs on our spinning Earth, the oceans respond, giving us high tides in some parts of the world and low tides elsewhere. And while the wind gives the waves their energy, tides define their shape. The moon's gravitational attraction also keeps us at a stable 23.5-degree tilt relative to the sun, giving us 4 seasons and a livable climate. But what if that livable climate were to suddenly become unlivable? With the moon gone, its stabilizing effect on the Earth's rotation would go with it. Want the good news first? The weekend just got a whole lot closer. If the moon suddenly disappeared, a day on Earth would only be 6 to 8 hours long. Over millions of years, shifting tides and their pressure on the Earth's continents have slowed our planet's rotation, giving us 24-hour days. But without the moon's strong gravitational influence, the world would spin 3 to 4 times faster than it does now. Here comes the bad news. Rotating at that speed, we would experience winds up to 480 kilometers per hour. Birds and insects would have no chance of survival. The luckiest land-based organisms would either be deeply rooted plants or very short, very stout animals. Most of our marine life would be wiped out, since sea creatures that rely on ocean currents for survival would lose the privilege of the ocean's pull. Currents help circulate vital nutrients from the ocean floor to the surface, while dragging oxygen-rich surface water deep into the sea. We'd still have tides, but now they'd be governed by the sun, and from a distance of 93 million miles away, they'd only be 1/3 as powerful. And with the moon suddenly out of the way, the oceans would rip towards the sun, causing catastrophic waves, killing thousands and submerging coastlines. At this point, we'd have to adjust to new ocean currents, which, circulating at a slower rate, would be heating up equatorial waters while turning polar waters frigid. These extreme differences would produce a similar effect on land as well, since ocean temperatures influence their regional climates. Along with the Sun, Mars and other nearby planets could also claim a share of gravitational influence over our planet, pulling Earth in different directions and causing it to tilt with increased volatility. Earth's axial plane would vary some 10 degrees, causing dramatic shifts in seasons and rendering our climate uninhabitable. Most crops would die with the drastic temperature changes. We'd experience the worst ice ages known to man, as huge glaciers from the North and South Poles would encroach upon the Earth, covering everything except perhaps a small band across the equator. So while full moons may attract werewolves, that's still better than an alternative world where the moon doesn't exist.
Buckle up! We're going to take the orbit of this rock and kick it into high gear. Behold the moon breaking its planetary speed limit. How would this event flood cities? What would happen to the Earth's crust? And why would the moon go rogue? This is What If, and here's what would happen if the moon orbited Earth faster. The moon orbits around our blue marble of a planet at a comfortable and reliable speed of 1 kilometer per second. And if that seems fast to you, well, hold on, you haven't seen anything yet. So how could this happen? If the moon kept getting closer to Earth, the gravitational pull from our planet would increase. That would make the moon's orbit speed up tremendously. That's the basis for Kepler's third law. So, if the moon kept creeping toward Earth, it would orbit faster and faster. And if that happened, how would this event freeze the planet? Every 27 days, the moon completes a trip around Earth. Well, not anymore. Get ready to see this celestial body more often. And with the moon's increased visibility and speed, lunar eclipses would be a regular sight. But that lovely view in the sky wouldn't make up for the hell on Earth below. If the moon moved closer, the gravitational pull would rip into the Earth's crust. This increased force would create earthquakes and increase volcanic eruptions across the globe. And don't think you could cool off by the ocean to escape the heat. Let me explain. The oceans ebb and flow thanks to the moon's orbit, the Earth's gravity, and the sun. So, as the moon inches closer, the ocean tides would become much larger. How large are we talking? They would be 8 times higher than average. Coastal cities would flood, and some islands would become blanketed underwater for most of the day. Almost 700 million people living in low-lying coastal areas would be in constant danger if they weren't evacuated. But what would happen if the moon started to move even faster? Well, remember Kepler's third law. The moon would only orbit faster if it got closer. Now, if it came within 18,470 kilometers, it would reach what's called the Roche limit. That's the point where the moon is so close to Earth that the tidal forces between us would get strong enough to tear this gray rock apart. Thankfully, this wouldn't be able to happen because as its speed increased, our moon would be launched into the cosmos. Yeah, that's because once our natural satellite reached 1.4 kilometers per second, it would have enough momentum to escape Earth's gravity. As it fades from sight, you might feel relieved at first. After all, the Earth's rotation would slow down without the moon, so days would become longer. And finally, you'd see an end to the constant earthquakes and devastating floods. But in reality, this is where the real nightmare begins. The tides would become smaller and weaker without the moon. Any coastal ecosystems that weren't already destroyed by the massive flooding would now be completely upended.
without churning tides, animals that depend on food sources normally floating in the ocean wouldn't get the nutrients they need to live. And without the moon's light, nocturnal predators would have difficulty completing a successful hunt. This could create a mass extinction event of creatures on land and at sea. And while life on Earth would be flipped on its ear, so would the planet. Earth has a tilt of about 23.5 degrees. This angle of its orbit makes the seasons possible. But it's the moon's gravity that stabilizes this tilt from going any further, so without it, the seasons could stop. Weather patterns might hold in place until the end of time. But if the tilt increased, well, it could cause extreme weather conditions, and once again, the Earth could be plunged into an ice age. Yeah, a faster lunar orbit could fast-track all life on Earth to extinction. No, that's not Photoshop. That's an actual video from the International Space Station of the moon looking a bit squished. Wow. So, what happened here? Is the cover-up behind a flat moon an elaborate government conspiracy? How would this affect the oceans? What would happen to our climate? And could the moon fly out into space? This is What If, and here's what would happen if the moon was flat. In 2010, an astronaut on the International Space Station observed a bizarre phenomenon. When he glanced out the window, he saw the moon looked flattened when it appeared in the thickest part of the Earth's atmosphere. And those of you in the Flat Earth Society, don't at me, it's not flat. High above the planet, the air bends light to give the moon this squished look in these very specific conditions. But if the moon were flat, it would explain why we never see the mysterious dark side. And if this was our reality, how would this affect gravity on Earth? Okay, there are no illusions this time. The moon is flat. So, how would that happen? Well, a celestial body would need to spin incredibly fast to become a flat disk. So fast that it would rip into tiny pieces before it would ever have a chance to form. For our purposes, let's say the moon survived this process and formed like a plate. Would this flat moon have the same mass as what we see right now? Well, as a flat disk, the moon could have 25% of the thickness, but the width might remain the same. With so much less mass floating above the Earth, the change in ocean tides could be the first noticeable effect. The moon's gravitational pull generates these tides. Our moon pulls the water on the side of the Earth that's closest to it, but this flat moon would have less mass and less gravitational effect on our planet. And the altered tides would affect more than just surfers. Ocean tides stir up material below the water's surface, allowing coastal ecosystems to thrive. Without the usual strong waves, animal life in the oceans, like crabs, mussels, and snails, could die off in mass numbers. This chain reaction could decimate life worldwide. And that's not all a flat moon would ruin. Remember, the tides also push water back and forth around the planet. When warm waters travel from one area to another, these tidal forces change weather patterns globally. Without the strong tides, we could experience extreme temperature changes. But even with all these devastating changes, the climate still wouldn't change as fast as the days. The moon's mass influences our planet's rotation, giving us a 24-hour day. But with a flat moon, the day could be only 15 hours long.
but I think most of us could live with a 5-hour workday. And while we'd get more sunlight, the nights would be even darker. You see, the moon reflects the sunlight to give off that bright glow we all know and love. A smaller moon would reflect less light, making it much dimmer. That would make it harder for nocturnal animals that rely on the moon for navigation and hunting. But maybe none of that would matter since it could potentially crash right into us. Wait, what? Yeah, the Earth and the Moon are locked together in an eternal dance. The motion created by one affects the other. I know, this sounds hippy-dippy, but trust me, we're talking science here. The same tidal forces that move the oceans also affect the Moon's orbit. The tidal bulges in the ocean rotate faster than the Moon orbits the Earth, and this rotation takes energy away from the Earth and transfers that into the Moon's orbit. This is called tidal friction and causes the Moon to drift away from us at the rate of 3.82 centimeters every year. A flat moon with less mass would orbit closer to our planet. So maybe it wouldn't slam into Earth, but our view of celestial phenomena wouldn't be the same. Right now, the sun and moon are positioned just perfectly that when aligned, we get a spectacular image of a total eclipse on Earth. The moon covers the sun entirely in this breathtaking event. A squished moon wouldn't be able to block out the sun entirely during an eclipse, and we would see the top and bottom of the sun peeking out. A flat moon could destroy the balance of life on Earth and threatens every ecosystem and living organism, including humans.
Greetings, future, moonling? Yeah, that's right. You are among the first generation of children born on the moon. How would your birth compare to every previous human's? Would your body be physically different from an Earthling's? And what challenges would you face if you traveled to Earth? This is What If, and here's what would happen if you were born on the moon. If you were born on the moon, you'd begin your life 384,400 kilometers away from where every other human being has ever been born. At least as far as we know. The surface of your birthplace would have an extremely thin atmosphere without liquid water. The radiation levels could be up to 1,000 times higher than on Earth's surface, and the scorching daytime temperatures at the equator get as high as 120 degrees and as frigid as minus 130 degrees at night. Of course, your mother wouldn't give birth to you out on the moon's surface. Your life would begin in a state-of-the-art base surrounded by a handful of astronauts. But with 6 times less gravity than on Earth, would being born on the moon be extremely dangerous? Right now, a moon base is only theoretical. Your first home on the moon might be a habitat based on Project Horizon. It was a concept proposed by the US military in 1959. Whether the base got built into caves using pressurized airbags or a high-tech cylindrical airlock dug into the surface, you'd be born into an incredible self-sustaining habitat. You'd harvest the oxygen you'd breathe and the water you'd drink from the moon's natural environment. Your birth wouldn't have been a walk in the park for your parents either. Since you'd be the first space baby, there wouldn't be any research on the challenges of conceiving a child in space. But your folks were successful, and you probably wouldn't want to hear much about that anyway. The moon's lower gravity would have made your birth especially challenging. As a fetus, you'd have developed slower, so the length of time your pregnant mother carried you could have been longer than on Earth. Imagine being pregnant in space for up to 1 full year. Your birth would likely have taken longer than back on Earth, too. For every month your mother has spent in space, she could have lost about 1 to 2% of her bone density. That would have made pushing you out a lot more difficult and dangerous. With the risk that giving birth could fracture your mother's pelvic bone, the doctors in your space habitat would have brought you into the world using a C-section operation. And every baby born on the moon after you would likely be born this way too. This could lead to one of the first big differences between Earth and moon babies. Our heads evolved to be small enough to fit through the birth canal. So, with no traditional childbirths on the moon, future moonlings could evolve to have bigger heads than their Earth counterparts. Moon-born children could even evolve to have different skin color than the folks back on Earth. The melanin in our skin protects us from the sun's radiation. And the darker your skin, the more natural protection you have. But there's no atmosphere on the moon, so you'd live with significantly less protection from radiation. So the skin color of future moonlings could evolve to be extremely dark to provide the protection they'd need. But since a lot of your life would be spent inside a habitat or wearing a spacesuit, well, the opposite could be true. Humans on the moon could evolve to be even paler than some people on Earth. The increased radiation could cause other changes too. If Earthlings and Moonlings didn't produce enough offspring together, you could even see a new species of humans emerge. Okay, well, that could take a few hundred or even thousands of generations, but you'd have been the starting point in this incredible evolution of humanity. How much you interact with people from Earth would be a tricky question for you. Not enough mingling, and your immune system could weaken. You could lose your ability to fight off infections brought to your base by visitors. To be safe, you might minimize your contacts with new astronauts or settlers. The last thing you'd want is to start the first pandemic on the moon. And if you ever made the trip to Earth, you'd find it pretty hard to adapt. First of all, you'd need a week or two just to adjust to the gravity. And you'd be plagued by lightheadedness each time you stood up, since the reflexes that regulate your blood pressure would be accustomed to lunar gravity, not Earth's. Be careful when jumping into any bodies of water, too. You're from a place where you have to live inside and conserve water, so diving could be hard for you. You could get disoriented and accidentally dive deeper instead of returning to the surface. Now, you could find that having a good view of the Earth makes up for the challenges of visiting it. If you live on the near side of the moon, you'd be able to see Earth all the time. Earth would even cast extra light onto you. Yeah, the Earth reflects approximately 37% of the sunlight it receives, so on the moon, your view of the planet could be 43 times brighter than the view an Earthling has looking up at you. Hopefully, you wouldn't grow up to be a light sleeper who needs total darkness. You awake? Yeah. You'd be constantly bathed in both sunlight and earthshine. Well, if that happens, maybe you could move over to the far side of the moon and enjoy its constant darkness. And with such a thin atmosphere, you'd see stars even during the brightest parts of the day. Being born on the moon would come with its pluses and minuses, but would it be even cooler if you were born somewhere else?
Like on Mars? Well, that's a story for another What If.
Imagine if one day you looked up into the night sky and saw Mars or Saturn, where the moon was supposed to be. That would sure turn our Earth into an alien world. And not just because of the new view. How would replacing the moon change the Earth's orbit? What planet could we safely replace our moon with? And what planet would be the most disastrous? This is What If, and here's what would happen if another planet